Okay, so let's go ahead and take a closer look at our transversal situation because there is a lot going on. As you can see, I even confused myself a little bit on the last video. But again, the transversal is the actual line that intersects the parallel. And when we do that, we form 8 angles, right? And 2 vertical angle situations, right? So there's one vertical angle situation, here's another, and so we know we already have some equality because of that. 1 was equal to 4, 2 was equal to 3, 5 was 8, 6 was 7, because of the 2 sets, right, of vertical angles that we've created. But adding to more language and some more equalities, if you would, the first one I want to address is this concept of corresponding angles. All right, essentially because these 2 lines are parallel, right, the situation, right, we have 2 angles that actually correspond to each other, and that makes them to be equal. So our first set, 1, right, is actually corresponding to and equal to angle 5, right, because if we take a look at this, again, these are parallel lines. This transversal is the same line, and so this picture here is geometrically in shape the same as this picture here. Right, and so that basically means that 1 and 5, not only are they corresponding, it's pretty much the same picture. I mean, essentially I could take this picture, pick it up, put it over, and 5 would cover the 1, right? And because it's the parallel lines, they're the same. So 1 and 5 are corresponding, which makes them equal. If I stay on that side, 3 and 7, right, are also corresponding, okay, and they are equal. So that's what we mean by corresponding sides. They're on the same side of the transversal, if you would, and then they correspond to each other, you know, because the picture is essentially the same. If I, again, put 1 on top of the other, 1 would be right on top of the 5, and 3 would be right on top of the 7, and they would be the same picture because of all the geometry going on. And of course, if we go to the alternate side, right, kind of getting some language, so if we go to the other side of the transversal, we have the same thing, right? 2 corresponds to 6, which means they're equal, right? 4 corresponds to 8, which basically means that they're equal, right? So that's what we mean by corresponding angles. And because of the geometry going on, right, that means the corresponding angles, so the same side of the transversal, right, but just a different set of the vertical angles. So we have this vertical angle situation and that one, but they're mirror images of each other. So 1 is to 5, 3 is to 7, 2 is to 6, 4 is to 8, all right, in terms of correspondence. All right, as you kind of heard me say, I talked about alternate. When we're talking about alternate, we're talking about being on different sides of the transversal. So this side is the alternate side to that side or vice versa. So that's what we mean by alternate. So when I talk about alternate interior angles, here's what's happening. I'm talking about being in the interior, right? So we're on the inside. So we're basically talking about angles 3, 4, 5, and 6. But we are alternating, which means that we're talking about the angles on flip sides. And what we also have are some more equalities because of the corresponding angles, right? So the first set of alternating interior angles would be 4 and 5. They're interior and they're on different sides. So 4 and 5 are one set of alternate interior angles. Of course, the other set, if we stay on the inside and alternate, it'd be 3 and 6. Okay, 3 and 5 are not alternate interior. They're interior angles, but they're not alternate because they're on the same side. 4 and 6 are interior, but they're not alternate because they're on the same side. So there's in the inside, there's 2 sets of alternate interior angles: 4 and 5, and 3 and 6. Of course, if we take a really close look and talk about all the situations, it actually turns out that these guys are actually equal to each other, right? And the reason being is because we know that 1 and 5 are already equal, and then because of the vertical angle situation, we know 1 is equal to 4. So if 1 is equal to 4, right, and 5 is basically equal to 8, right, these are the same pictures, right? And so 1 is equivalent to 5, 1 is also equivalent to 4, so that means 4 is also equivalent to 5. And the same argument can be here, right? So we know that 2 is equal to 6, right, because of the correspondence. 2 is equal to 3 because of the vertical angles, so that means that 3 must be equal to 6 because of the alternating interior angle situation. So we have another situation of equality for alternate interior angles. Of course, the same thing happens for the exterior. This time we're on the outside, right? So we're talking about angles 1, 2, 7, and 8, and we're talking about being on alternate. So if we look on the outside and opposite side, so the exterior angle 1, its alternate exterior angle would be 8. right? And then the other set, if we go to the other side, the exterior angle 2. On the alternate interior exterior, it would be 7. So 2 and 7. And of course, it turns out that these are also equal for all the same situations, right? So we know that basically that 1, right, is, let me make sure, I lost my train of thought there, sorry. So we know that 1, right, is equivalent to 4, and 4 is equivalent to 5, and 5 is equivalent to 8. So if you follow those equivalency arguments, 1 has to be the same thing as 8. All right? Or in essence, since 4 is equal to 8, that means 4 is equal to 1. That means 1 is also equal to 8. So lots of ways to kind of see that. The other one, 2 is to 7. Well, 2 is equivalent to 3. 3 is equivalent to 6. And 6 is equivalent to 7. Right? So that must mean that 2 is equivalent to 7 as we kind of go through that little arc right there. So 2 is equivalent to 6. Right? And 6 is equivalent to 7, so that means 2 must be equal to 7. So we have two sets of alternate exterior angles, and those two sets are actually equal to each other. 1 is to 8, and 2 is to 7. One last lingo that's kind of important is the idea of an interior same side angles. All right, and it turns out when we're interior same side, let's go take a look. All right, so if that's the case, we're talking about being on the inside, but on the same side. And so 4 and 6 would be one combination of interior same side angles because they're inside and on the same side, and that would mean that 3 and 5 would also be a set of interior same side angles. All right, and so because they're interior, they're on the inside, and they're on the same side of the transversal. And it turns out when you look at the geometry of this, if you added angle 4 and 6 together, what you actually would get is 180 degrees. All right, and the reason being is for the geometry. If we just take a look at this transversal here, we know that 2 plus 4 would be equal to 180. And I'm talking angles, by the way, right? Angle 2 and angle 4. I'm not implying that 2 plus 4 is equal to 180, all right? I'm talking about the angle 2 plus the angle 4, right, would equal 180. That's just because of the straight angle that we have here. And if we go through this, we know that 4 and 8 are equivalent, right? And so if 4 is the supplement of 2 and 4 is equal to 8, then that basically means that 8 and 4 are essentially the same thing. Same thing, yes, they're 4 and 8 are the same thing. And so, and then the same idea here, right? 2 is equivalent to 6, right? And so since 2 and 4 add up to 180, that must mean because of the equivalencies 4 and 6, if I added angle 4 and I added it to angle 6, those angle measurements would be equal to 180. And the same thing because of all the equality going on, because 1 and 3, right? Angle 1 plus angle 3 would sum up to 180 because of the straight angle. But since 1 is 5 and 3 is 7 and all that other good stuff, it turns out that angle 3 and angle 5, if I add them together, I would also get 180. So those are the big four that tend to be used a lot in the homework and things of that nature. Of course, if we sat and we thought about this for a while, you know, we would probably see a lot of other relationships. There's so many things we can say. But again, the big ones are what it means to be corresponding, right? So that again means we're on the same side and kind of in the same place value, if you would. Again, if we imposed one picture on top of the other, it's the same. So there's that idea of corresponding angles being equal. Alternate interior angles are equal, so 4 is equal to 5, 3 is equal to 6. Alternate exterior angles, 1 is the same as 8, and 2 is the same as 7. And then the fact that interior angles on the same side, right, are basically supplements. That's essentially what we're saying there. I don't even know if I spelled supplements right. Their sum equals to 180. All right, so that's basically, again, a closer look at transversals. Of course, now we got to go look at some homework problem, which I'll do a little bit after we talk about some triangle situations. All right, so more later. Hopefully that gives you a pretty good idea of some of the basic terminology. Lots of things to learn and to think about. Talk to you guys later.